Good morning, good afternoon, good evening, everyone, and thank you for joining. Before we start, quick intro. I have here Ovidiu with us. Ovidiu is our Director of Sales and Marketing. He's handling the chat and questions. Ovidiu, you're the mastermind behind this webinar. Please tell us why we're doing it.
When I talk to CTOs in healthcare, I keep seeing the same pattern. They think that getting a HIPAA compliant infrastructure on AWS means 9 months long project or a 12-month long project that also costs a fortune. And if you want me to be honest, that's true if you are building your app first and trying to re-architect, rethink it in terms of compliance later. But if you design with compliance in mind from the start, you're not looking at months of deployment, or you're looking at weeks. The problem is that most technical teams don't know exactly what compliant from day one or compliant from the start means in AWS, what it looks like, what do you have to configure. So that's what we're actually showing today, the specific architecture decisions and practical approaches that make HIPAA compliance fast and sustainable for any kind of application running in the cloud.
Right. So most of the pain, as you said, comes from doing it backwards. You're building your app first, and then you're trying to make it compliant later. And we're trying to show you how to actually avoid that. We're going to spend the next 30 to maybe 45 minutes on something that keeps a lot of CTOs and technical leaders awake at night. Getting to HIPAA compliance in AWS without it taking months, as you said, and burning through your entire infrastructure budget. This session is thought to be mostly practical. We're not here to read you the HIPAA statute. You can definitely go ahead and do that yourselves. We're here to show you the exact technical architecture and automation approaches that get healthcare companies from we need to be compliant to we actually have our technical safeguards in place in weeks and not months. Hopefully, by the end, you'll walk away with a clearer picture of what multi-account architecture looks like, what exactly is enforcement in infrastructure as code, and how continuous compliance monitoring looks like. And for those of you who want to see it in action, we'll definitely show you what it looks like in a real environment later in the session. So let's start. Quick context on safeINIT before we get into it. We are an AWS Advanced partner. We are AWS exclusive. Our only focus is AWS. We have 60 plus certifications across the team. We have 2 competencies and 7 plus service validations, which includes the resiliency competency, which relates to what we're covering today. At safeINIT, we help companies deploy and operate AWS environments that are secure, compliant, and ready to scale. We combine technical depth with a clear understanding what the business and regulatory realities look like. Our specialty is healthcare and AI businesses, companies where the regulatory complexity intersects with the technical requirements. We've been doing this for a long time. We've been architecting compliant infrastructures ranging from early stage telehealth startups to enterprise medical device businesses. And we'll talk a little bit about these as we move along. Why are we here? And before we talk about these numbers and this very large exclamation mark on the screen, just a quick recap on what HIPAA actually means and why you should care about it in the context of AWS. HIPAA, as you guys are aware, is the Health Insurance Portability and Accountability Act, and it basically dictates how you are supposed to handle personal health information or electronic personal health information, patient data, patient records, etc. But unlike the ISO standard or unlike the SOC2 standard, there's no official HIPAA certification. You don't get a badge to hang on your wall. And instead, HIPAA defines 3 types of safeguards that you must implement when dealing with EPHI. First of all, you have technical safeguards, which relate to encryption, access controls. This is what we're focusing on today and where the AWS infrastructure comes in. You then have administrative safeguards, which are policies, procedures, training, who has access to what, how you onboard employees, and incident response plans. Then you have physical safeguards, which mostly relate to data center security, workstation controls, device management, etc. So for the better part of it, AWS handles it. You are supposed to handle it for your offices and devices. You can be audited by regulators or assessed by customers before you sign your BAA, but all three safeguard types matter. Today, as I said, we're focused on the technical infrastructure piece. And now we're talking about the numbers on the screen. So we have $7.4 million, and that's the average cost of a healthcare data breach in 2025. Not the maximum, the average. 74.1% of data breaches in Q3 2025 came from healthcare providers. And healthcare isn't just some target, it's the primary target. And then 276 million patient records were exposed last year alone. I know it might sound scary, but these are the actual stakes when you're handling EPHI. The question isn't whether you need strong security, right? I think it's obvious. The question is how you implement it without having to take 6 months and without burning your entire infrastructure budget. That's what we're here to try and solve: how to get compliant infrastructure deployed quickly and correctly. I'd like to talk about common roadblocks that we've seen at safeINIT about implementing HIPAA architectures or HIPAA infrastructures. So here are the 5 most common that we've come across. So first of all, we have services which are misconfigured for handling EPHI. What does this mean? Let's take, for example, somebody sets up storage for patient data. They forget to turn on encryption or leave access settings to open. So these aren't necessarily malicious, but because of the complexity of the services in AWS, there are simply configuration mistakes. But that doesn't mean that they aren't compliance violations. Number 2 has to do with how you audit and how you monitor your environment. As a general rule, HIPAA requires you to know who accessed what data and when. That means you need to implement comprehensive logging across your entire environment. Most teams enable logging in some places, but miss others. Incomplete logging means that you can't actually prove compliance. Next, we've seen an unclear encryption strategy. Encryption is mandatory for patient data, let's just leave it at that. But teams get confused about what needs to be encrypted, how to manage the encryption keys, and which tools to use. Without having these clear guidelines, without having the clear strategy in mind, you're simply guessing. What about network isolation? Running everything in one environment with no separation between production and development. That's what we're talking about. We have no boundaries between different parts of our system. This definitely creates security risks, and it violates the principle of limiting access to only what's needed. And finally, most development teams are definitely great. They're amazing at building applications. However, they are not experts in HIPAA requirements or AWS security. You either pull engineers off of the product work to learn this, or you hire expensive consultants. Either way, it definitely drains resources. We also have this nice image on the right. These actually map out to the core layers that you need. You need network isolation, you need identity management, you need encryption, monitoring, and definitely you need workload security. All of these layers definitely work together. Let's get specific on the reason why compliance initiatives stall. Of course, what a successful implementation looks like. First of all, you've probably heard about this thing called the shared responsibility model. Basically, what it means is that AWS takes some of the responsibility in the sense that they provide security of their data centers, they provide security of the hardware which is installed on site. Access to these components is definitely secure. But on the other hand, you're definitely responsible for the other side of the picture, your application. Teams usually think, yeah, we're on AWS is compliant, therefore we are compliant. And that's not how it works. The confusion comes because AWS signs the business agreement addendum with you, but that just means that AWS agrees to handle their part correctly. It doesn't automatically make your application compliant. You still need to configure everything properly on your side. Talking about the process of collecting evidence and documenting. Usually that's manual, and If you need to prove compliance, if it's for regulators or customers, you definitely need these pieces of evidence in place. And these can be things such as configuration screenshots, access logs, encryption verification, audit trails, these sort of things. When teams do this manually, it's a nightmare. You have hundreds of hours of work collecting screenshots and exports, very high error rate. And of course, you're always worried that you've missed something, and this doesn't scale. Every time you add a new service or an environment, you're back to manual evidence collecting. The only sustainable path is automated evidence collection that runs continuously. We're now talking about the most expensive mistake, which is retrofitting compliance. You build your application first, get it working, get customers, then try to add compliance afterwards. This is, I think, the most common pattern that we've seen during our deployments. What it means is that you have to rebuild architectures, you have to migrate data, you have to deal with downtime, you have to retest everything in order to get your environment compliant. Your team is frustrated, of course, because they're redoing the work which is already finished. This is specifically what adds months and burns budget. Now, on the lighter side of things, I'd like to quickly touch upon two of our success stories, I2I Connect and rXperius. We've been working with I2I Connect for a number of years now, I think close to 4. I2I Connect provides a very great service that has to deal with telehealth, with remote therapy care. They're dealing with vast amounts of highly sensitive customer data. Definitely they needed a secure environment, which was HIPAA compliant, and we're very proud of what we've achieved together with them. They do have a resilient architecture, faster scaling time, and they did reduce their overall costs by implementing our HIPAA compliant environment. Next, we also have rXperius, which deals with providing customer survey information based on the medication that these customers are taking. They get all this data, they provide analytics on what works and what doesn't. Needless to say, there is a lot of private information there, so of course they needed something secure. I would definitely encourage you to read more on these stories because we've provided a lot of technical information and how we've managed to achieve this by visiting our website. Go to safeinit.com/success-stories and read on. How exactly do we plan getting HIPAA ready and what that actually means technically? If you take nothing else from this webinar, you can take this slide for sure. These are 5 non-negotiables that will get your infrastructure HIPAA ready in AWS. First of all, you need to go with a multi-account strategy. If we're talking about AWS, an account is like a separate container for your resources. Multi-account means instead of putting everything into one place, you separate things into different accounts based on their security role. Okay, why? Well, if someone breaks into your development environment, they can't touch your production data or delete your audit logs because those are in completely separate accounts with different access controls. You get isolation and containment. This is AWS best practice for any serious deployment, not just compliance, not just HIPAA. Second, use infrastructure as code. We are using OpenTofu, which is the open source fork of Terraform. So instead of clicking through the AWS console to set up things manually, you define everything in code files. Your network setup, who can access what, encryption settings, logging rules, all is written as code. Why does this matter? Because the same code creates the same secure setup every time. There's no human error from forgetting a step. You can review changes before they happen, and everything is tracked in version control. Without having this, everything is manual work that has to be repeated perfectly every time. Third, encryption is mandatory. All patient data must be encrypted, both when it's stored and when it's moving across networks. There are no exceptions on this. This should be enforced by your infrastructure code. So in case there's an accident, engineers don't forget to turn it on. You need to make it impossible to create storage without encryption enabled. Centralizing audit logging. Every action in your AWS environment needs to be logged. Who did what, when, from where. All those logs go to one dedicated account that's logged down. Even administrators can't delete logs from there. Why centralized? Again, if somebody breaks in, they'll try to delete logs to cover their tracks. Centralized lockdown logging prevents that. Finally, make sure that you monitor your environment for compliance. You set up monitoring that consistently checks your environment against against compliance rules. Is the storage encrypted? Are these access permissions too broad? Is logging enabled everywhere it should be? You need to get real-time alerts when something drifts out of compliance. This is how you maintain compliance ongoing and not just achieve it once and hope that nothing changes. These 5 controls form the foundation. Now let's look at how they fit together in a real architecture. We briefly mentioned the multi-account architecture with isolation. Let's talk about what these accounts should do. This is not something that we have invented. This is straight from the AWS security reference architecture. This is their best practice. Let's talk about the main accounts that should be part of your organization. First of all, we have the management account. This handles stuff like billing and setting up organization-wide rules. This controls permissions across all your other accounts. The critical thing is that you don't run applications here. This is purely for governance and control. The security tooling account. This is where all your security monitoring lives. It collects security alerts and compliance status from all your other accounts. Your security team can see everything here, but they can't accidentally break production while investigating issues. We're talking about the log archive account as the vault of your organization. Every log from every account flows here. Who accessed what, when, from where. The key thing is that these logs are locked down so tight that even administrators can't delete them. This is your immutable audit trail. Only then can we talk about the actual workload accounts. This is where your actual applications run and where the patient data gets processed. You have separate accounts for production, for staging, for development, maybe even for QA. If someone breaks into your dev environment, they're stuck there. They can't even get to the production data. And then you even have the shared services account. This runs the tools and services that all your other accounts need to use, but that don't handle patient data. These are things such as the CI/CD pipelines, your directory services. You want to keep these centralized so you're not duplicating them everywhere. The key benefit is isolation. If an attacker gets into one account, they're contained there. They can't delete logs, they can't turn off monitoring, they can't jump to other environments. This isolation is what makes compliance sustainable as you grow. Multi-account architecture is definitely the what. The infrastructure as code is the how. We'd like to break down these 3 specific examples on how to use infrastructure as code to enforce compliance controls automatically. Talking about encryption enforcement, your infrastructure code templates require encryption for any storage that holds patient data. You literally cannot deploy something unencrypted. The deployment will fail. This removes the possibility of somebody forgetting to check the encryption box. This is how you would use your code to enforce this. Next, we're talking about access control. When you deploy a new application component that needs to access data, your code automatically generates the minimum permissions needed. Read-only access to just the specific data it needs and nothing more. No one is manually creating permissions that might be too broad. There are no long-lived passwords sitting around. Everything uses temporary credentials that expire. Audit logging. When you set up a new account or environment, logging is automatically enabled as part of the setup. You don't deploy something and then remember to turn on logging afterwards. That's not how it works. Logging is part of the foundation and it's there from the start. As we mentioned, all logs automatically route to your locked down log archive account. Policies are automatically set to logs that deem that these cannot be deleted. Infrastructure as code ensures that you deploy the same secure setup every time automatically. No human error, no missed steps. Talking about continuous monitoring and cost control. Compliance isn't something that you set up once and forget. It's continuous. Here's how we actually maintain it real time. AWS Config and Security Hub are services that constantly check your environment across the compliance rules. You have centralized dashboards. It pulls together findings from all monitoring tools. And when somebody asks, are you compliant? You just pull up the dashboards and you can show them the real-time status. Real-time alerting. This is critical. In case something goes wrong, you want to be immediately notified. If somebody creates storage without encryption or opens up access too wide, you want to be alerted within minutes. You can fix it immediately and not discover it in months or later during an actual assessment. cost control, because I know that some of you are thinking, yeah, this sounds very expensive. Multiple accounts, encryption everywhere, all this logging. I'm not going to sit here and tell you that running a HIPAA compliant environment is cheap, but infrastructure as code lets you provision exactly what you need. You're not guessing at the sizes or over provisioning just to be safe. You define what you need, deploy it, monitor actual usage, and adjust. This eliminates waste as much as possible. In terms of lifecycle management, you have your non-production environments, which are dev, staging, testing. These can automatically shut down on nights and weekends. Environments spin up Monday morning, shut down Friday evening. You're paying for 40 hours a week instead of 168. The infrastructure definitions stay compliant whether your environments are running or not. Compliance is in the code, not in the running resources. Compliance built in from the start costs less than compliance added later. When you retrofit, you're migrating data, you're refactoring applications, you're dealing with downtime, paying consultants to fix what should have been done right initially. When compliance is built in, you deploy once correctly, no rework, no surprises. Ovidiu, do you want to maybe say a few words about this ebook that we have available and if people should be interested in looking at it?
Definitely. We made this a while back to help technical teams, first of all, get clarity about what exactly they should configure in AWS, how they should configure it. We also thought that it would be useful to have a glossary of terms related to HIPAA and specific technical stuff in the cloud. It's free to download. We would definitely love a feedback on it after anyone goes through it, just so we know what should we improve for the second edition, whenever that's coming. It's on safeinit.com/HIPAA compliance guide.
Wonderful. Thank you so much. Now that we've talked about it, let's see what this looks like in practice. I want to show you 4 things: the multi-account structure, the compliance dashboard, automated evidence collection, and continuous monitoring. This is a real safeZONE deployment. First of all, this is the AWS IAM Identity Center access portal. This is what you see when you log into a safeZONE environment. You have all these separate AWS accounts, each with a specific purpose. You can see them listed here. This is the multi-account isolation that we talked about. Production workloads are separate from development, security monitoring is separate from both, and logs are in their own logged account. If somebody gets access to the dev environment, they're contained there. They can't touch production data or delete audit logs because they are in completely separate accounts with different access controls. This is something that we've built. We're looking at compliance status. This is a quick site dashboard pulling data from AWS Audit Manager. It shows our compliance posture across all 3 safeguard types. We have administrative, we have technical, we have physical. Here you can see the overall compliance score. This shows that most evidence is compliant, with a small slice here that is not compliant or it's missing evidence. If we move then on the number of evidences by its section, we can see the number here. We can see the accounts of records by whichever section numbers. Of course, these are the section numbers that are listed by the official HIPAA documentation. Again, if you want to learn more about what these actually mean and how they relate to AWS, feel free to download the ebook from our website that has a pretty neat explanation on how it relates to the AWS resources. Moving on to the administrative safeguards. These are your policies and procedures. We have the technical safeguards. This is our infrastructure piece. We had the slight dip. That's because we deployed new resources that needs evidence collection to catch up. And then we have physical safeguards, data center security, workstation controls. We wanted to encapsulate all the safeguards, not only those that have to do with AWS resources, but the ones that you are actually supposed to provide manual evidence for how you work on your workstations, how you offboard and onboard an employee, etc. Moving on to the next resource that I want to share with you, the Audit Manager, an AWS native service that automates evidence collection for compliance assessment. We can have the controls, which are grouped by control set. We can see the number of total pieces of evidence for a certain control. For example, if we click on whichever control, we can see the description, and it says that we should implement mechanisms to encrypt and decrypt electronic protected health information. Seems like a pretty important piece of information to have. We we can see that we ran a compliance check and we have multiple data sources that were reading data continuously from our AWS environment and pulling evidence in order for us to show that we are compliant with this specific control. The last service that I want to show you, AWS config service with the HIPAA performance pack. This service actually continuously monitors all your resources. Let's check a non-compliant role. We can see the actual resource ID and everything that was run and at which date. Apparently the compliance changed because we saw the issue. This is how we actually monitor all of our resources.
We also have a question that came in earlier. Frank said that infrastructure as code sounds good, but I guess he's worried that it's slower.
It depends on what your actual needs are. Of course, it takes longer for it to develop the first time. It definitely takes longer to write code for a resource than it is to manually go into the AWS console. But what if you want to deploy it again? Or what if you want to deploy it 10 more times? That's where the power of infrastructure as code comes.
And on this note, it just came to me, since everyone's talking about AI these days. Have you seen any large language model that actually helped you write some code that was later used in an infrastructure? Because I know all of them write code, but when you test the actual code, it's not the best.
That's actually an excellent question. We do have AI services which are implemented in our infrastructure deployment framework services, more on a consultative level and not an actual execution or decision-making role. We still rely on ourselves to go through the infrastructure plan and to make sure that what it deploys is correct. The GenAI services that we have implemented are very good for generating the documentation. They're very good at generating certain aesthetic elements of the code, not so much the actual execution. We do have our own style that we've built way before GenAI was a thing. We have our own standards, we have our own naming conventions. We found out that because the data that it has to go through is so large, we don't get consistent results one after the other. There's still a man in the middle, for sure. I guess the core message of what we're trying to say is that compliant by design is not just faster and cheaper than retrofitting compliance. I think it's the only sustainable approach at scale. If any of today's topics raise questions about your environment, we can definitely walk through them together. Reach out at sales@safeinit.com. We're more than happy to chat. You can even book a call with us on our website to discuss your infrastructure HIPAA needs. I'm available on LinkedIn as well as Ovidiu. We're definitely eager to hear how you can challenge us. Thank you for your time and your attention.